Okay, and yeah, let's begin then. So first of all, I would like to invite you to join the Google Developers Online community on Discord. There's already people there seeing this session today. But if you are not there, I highly recommend you to go and join. It's really an amazing community, and you will find there really brilliant people. One of them is Faye. She's here as well today. So yeah, just follow that link and join this community because it's really amazing. Um, so as we have been doing in all of the sessions, if you have any question, um, if you have any comment, put it on the chat and I can stop like every now and then during the session to answer your questions. I can see here that someone is asking if we can have a Q&A session after the third one, which is going to be the final one. Yeah, of course, we can set up some time for that for sure. That will be awesome. The Discord invite is invalid for me. Faye, if you're here, can you please help out Karen um, to see what's going on with that link? All right, so let's start. So today we're going to be talking about the rest of the data structures. Since this is an introduction where we cover like the most important and common ones. So yeah, last session, we talked about the arrays, the maps, the dictionaries, linked lists, and the trees. And today we're going to do a quick recap of what we learned on the previous session. We're going to talk about the stacks, the queues, heaps, and graphs. And with that, we're going to cover all of the data structures. And then next session, that's going to be next week on Thursday, not Wednesday. It's going to be on Thursday at 7:30, like the same time. We're going to be talking about algorithms. And it's going to be cool. Um, we are not going to do it on Wednesday because I believe the web development bootcamp is going to start next Wednesday. So I believe it's gonna be, sorry, I think it's gonna be Mondays and Wednesdays. And I highly recommend you to go to the GDG Glasgow website and have a look at it. It's going to be run by the amazing Joe Franchetti. So if you want to learn about web development, it's going to be like an 8 sessions series. It's going to be really, really good. So I highly recommend you to go if you're interested. All right. So let's start with the recap. What is that we saw in the previous session? So first, we started talking about what are data structures and why do we need that. Why do we need them to in order to optimize the way we are coding, right? And optimize the way we are solving a problem through code. So in this image, uh, we talk about this example. Like for example, on the left, you can see a bunch of books, like a pile of books, and it's all like it's a mess. And let's say that you want to find a book there. It's gonna be kind of hard. You will need to. It's very disorganized. But on the right side, you can see that, for example, in a library, there is a system to have everything organized and everything. It can be labeled, so you are going to be able to find what you're looking for in a more quick way. Like it's going to be faster, and obviously it's going to be better. So working with data structures is similar, right? You would like what you want to achieve is to have a faster, better, more optimized way to find the data that you need, that might be stored in memory or on a, yeah, let's say is how is it stored in the computer. All right, so in that way we can work faster way. Then we talk about like the memory hierarchy. Oh, I forgot again how to pronounce this. I remember uh, Liz gave me some tips on how to pronounce this on the last session. Hierarchies. So yeah, um, first we have like on the top we have the register, so that's on the CPU. It's the smallest in size, but it is the fastest in speed. Then we have the cache memory. Then we have the main memory. Yeah, thank you, Delia. Then we have the main memory, where you can find the famous RAM memory. And that is a memory that everything that you put there you're going to lose it as soon as you turn off the computer. And then you have like secondary memory, which can be like a hard disk or a flash drive and so on. And of course, um, depending on this, that's why we need to optimize the way we are storing the data. And for that, the data structures are pretty useful. Okay, then we talk about why data structures are actually important. And again, an efficient way to access data, to manipulate the data as well. It's better, it helps to optimize the way we use the memory. Um, Certain types of data structures allows us to solve problems in a better way, and our algorithms can be more efficient, and the complexity of dealing with certain type of data um, can also be reduced depending on the data structure that we choose, and so on. Then we started talking about the data structures. So we're starting about talking about the arrays, which is just a collection of items. And depending on the programming language that you're using, they have to be like all of the same type, or there are other programming languages that allows you to mix in an array, let's say, numbers and a string, for example. Then we talk about the properties, the advantages, and the drawbacks, and when is the ideal use case for using arrays. Then we did the same with the maps and the dictionaries. We also had a look at how they work and what are also like the properties, the advantages, and all of the characteristics and attributes. Then we talk about linked lists, which are also pretty fun. And again, is a way to relate data to another piece of data. And it doesn't have to be stored like in a sequential way. They can be stored in different places, but there's always like a pointer to the next, let's say, node, as you can see on the graph. And then we also talk about properties, advantages, what are the drawbacks, and when is the ideal situation to use the linked lists. And then we talk about trees. And today we're going to be talking about something that is very, very related to trees. And we also talk again all of the properties and everything related to the trees. So if you want, you can go back, have a look at the YouTube recording for that session. And if you were not there, you can just review everything. And if not, it's always going to be there for you to have a look at. Okay, so let's start with what we're going to learn today. So first, we're going to talk about the stack and the queues. So again, this is another set of really interesting data structures, and hopefully you will get to understand when is the best situation, like what's the best case that you might find in your you know day-to-day work, or when you're studying maybe for an interview, a technical interview, to properly understand when is the best situation where we can use the stack and the queues. So let's talk about stacks. Like at some point, many of us we have to deal like in our lives with stacks. So it can be like a stack of pancakes. It can be I don't know, a stack of plates, or I don't know. The thing about stacks is that you have to arrange stuff and things one on top of the other. Okay, so let's think about the pancakes. You place your, like, maybe your cooking pie, cooking pancakes, and the first one is ready. You put it on the plate. The second one is ready. You put it on top, and so on. So the concept here is that every time, like when you deal with stacks, that you always have to add an item to the top. Okay, and if you want to remove something from the stack, you have to take it out from the top as well. So if you are working on cooking the pancakes and you start serving them, you're not gonna grab the one on the bottom, right? Because it's gonna be a mess. You grab the one that is on top. So that's the way stacks work as well on computers. Just you start putting stuff in it, and then from the last element that you put, you have to take it out. Okay, so this is how it works. Let's say we're starting with a first element, then on the first step we add another one on the top, then on the third step 2 another one, and so on and so on, and then by the end we have the stack 1 2 3 4 5. And then you can visualize this as is an array, right? And then what is that we have to do if we want to take out the elements? So it has to be in order. Just the one on the top, you start like to take them out and take them out and take them out until you have like the first element. The best way to think about it is like, think about pancakes. So this actually has a name in computer science. We call it the last in, first out. So or, well, in Spanish I used to say LIFO. I guess in English could be similar. And yep, it's a very easy way to remember how does it work. So I wanted to do some coding. So let me, just to show you how to do it in JavaScript. Let me stop this for a while. And okay, I'm gonna go here and share the screen. Isn't this one? Clean this up. No, this one. Can you see, or is it too small? Can you confirm if it's too small? Maybe I can make it bigger. No, maybe like this. Okay, so brilliant, thank you. So okay, hold on. Have to. Okay. Give me just a second. Okay. Sometimes I have too many screens. Sometimes that's not good. All right. Okay, I think we can continue. Okay, so remember the I'm going to create an array, okay? And we're going to put elements into the array. We're going to push elements into the array, and then we're going to take them out following the last in, first out, okay? So I'm going to be using JavaScript. So let's first define this array that is going to be called stack. Okay, and now we are going to push the elements. So we can do stack, and we can use this function that is called push. And we are going to put the first element. Let's push the second one. And then let's push a third one. Okay, so now we are going to see, let's have a look at how that array looks like. So let's see, stack after, actually, let's do something. Let's have a look at how does it look like when we push the first one. We can say stack with first element. And we can do the same for the let's have a look at how does it look like when we push the second one after pushing second element, and then how does it looks like after pushing the third element. Okay, so it's going to appear here on the console. I'm going to run it. Okay, so as you can see here, hopefully you can see that. Okay, so we pushed the first element, then the second, then the third, and as you can see, this is our stack. This is the first element, second, and third. Now, what we're going to do is that following that principle of last in, first out, the first one, like imagine that is the stack of our pancakes. So the first pancake, the second, and the third, but like you're looking at it horizontally, but imagine that it's like a vertical one. So of course we need to remove the third one, the third element first, because it was the last that got into the stack. Okay, so for that we're going to be using this function called pop. Okay, so we can do, let's say, remove the elements, and we can do stack, and if we do pop, if we just have to, like, if we say just pop, if we just execute that function, it's going to remove the last one. Okay, so now let's have a look. Stack after first pop, and let's see how it looks like. I'm going to clear this, and I'm going to execute it again. So as you can see here on the stack after the first pop, you see that it removed the last element that got into the stack. And then we would be doing that to remove everything. We just need to repeat this pop function until we remove all of the elements. So that's basically how it works in JavaScript. Okay, let's continue. I'm going to, what are you? Here. Okay, I'm going to move this here and expand this. Okay, Any questions so far? Any chance we could look into Python implementation as well? Yes, I can share it. Maybe, yeah, probably. Well, what I can do is that I can add another, like a slide with the code in JavaScript and the code in Python. I don't know if Jose is here today. I remember the last session, some people were helping out on the chat, like finding like those same functions for pushing stuff into the array and pop them out on Python. But yeah, I can add those to the slides. Okay, so let's have a look again at what are all of these information that we have been seeing for each of the data structures. So again, this is a linear data structure, and it follows the last in first out principle, as we saw, we just saw. So on the properties, again, that's the principle: last in first out. Only the top element can be accessed, so that's the only one that you can access. So you have to pop, like take out the element, and maybe you can put it in a variable, and then you can do operations. So the main operations are push, like we just said, push to add to the top, and pop to remove it. What are the advantages? It's very easy to implement, as you just saw. These operations are really, really fast. Thank you, Delia, for sharing the information about Python. Thanks. So yeah, these push and pop operations are really fast. And for example, here it says supports undo operations. You know, when you're writing something, let's say in I don't know, in Word, and then you press Control Z. What it does is that everything that you're doing on the let's say on Word is being stacked, and then when you press Control Z to undo, what you're doing is that you're removing stuff from the top. So that is actually a stack, and the way that it is implemented is using this kind of data structure. Um, what are the drawbacks? Well, if we are predefining the size of that array, then we can have a problem with that. So we're going to be restricted by the size. You cannot access the elements in the middle. So imagine again that example of the undo something on Word that you're pressing, like undo. You cannot go to something that you did like 3 steps before. It's just the last one, and so on and so on. Overflow can occur if used without checks. So overflow is when you don't have more space in you go to the last space in memory, and then you don't have more space to store stuff or to process stuff. So that can happen if you don't check the available space that you have, the available memory, and depending on if you are restricted by the size. Then what is the ideal usage? For backtracking algorithms, we're going to be talking about backtracking algorithms next week, an overview. Those are my favorites, but they are also quite tricky to understand at the beginning. It's very good for syntax parsing, for implementing recursion, and we are going to be talking about recursion next week as well. And then for this kind of applications, like we just talked about, undo functionality, maybe in your code editor or Word. All right, any questions about stacks? All right, now let's go to the next one. Let's talk about queues. So queues is a little bit different, okay? So let's say you are going to the bank, right? And you want to do an operation, or let's say you want to, you're gonna take a plane, and you start doing your queue, and you give your passport, your ticket to the lady, and then she allows you to go in the plane. So that's in order. So the first one that gets into the line is the first one that's going to get out of the line, right? Is going to get out of the line and get into the plane. So this is a little bit different, okay? So in this case, we have someone in, like, and then the queue can start growing. So a new person goes into the queue, and then the person that is on the first position gets out. All right. So this basically follows a different principle. So the first in is the first out. So let's have a look at this. We are again like creating the view, the queue, just as like the same, like the stacks. But the difference is how we remove elements. So as you can see here, in the case of the stacks, we would remove like the element that is on the top. But in the queues, we remove the element, like the first element of the queue, because it's like, just like if you're waiting in line, right? The first person that to be, I don't know, exactly, getting into the plane is the first one that goes out of the queue. All right. So um, there are many applications in software for using queues, and for example, this, if you are waiting in line to buy a ticket for this very famous concert of Taylor Swift that everyone was going crazy and Ticketmaster was going nuts, they have a queue system where you have to wait and wait and wait until like people on the front of the queues, they start getting the tickets and so on and so on. Or for example, you can also have a queue, let's say for I don't know, the emails that are getting into your inbox. They can arrive to the mail server like in queue, and then they can be redirected to each inbox and so on. It's used a lot. Okay. So, like I said before, this is a different principle. This is not last in, first out. This is actually first in, first out. So, if you are going to be, obviously, this is an introductory sessions. This is an introductory series into data structures and algorithms. But if you dive deeper into this subject, and you're going to study algorithms and so on, you will be reading a lot about first in, first out, and so on. So you're going to be seeing this in many places. Okay, so what we can do now is that we can have a look at how we can implement this using JavaScript. So I'm gonna move this here, and okay. This one. Okay, so what are we going to do now? Now this is a different implementation. So maybe what we can do is that we're going to create our stack. Now, what? So we can create a stack in the same way, right? We're starting putting like all of the elements in the stack. Just this case, this time around, let's call it Q, just for not to confuse us, because it's quite about the same. So we have our Q, and we're going to be adding, like, the elements are getting into our queue. Okay, so let's run this. And why are we not seeing this? Unexpectedly close the connection. Why? Oh, here it is. Okay, so let me run it again. Okay, so here we're seeing our queue. I forgot to print the third one. Okay, so let's print the third element so we can see all of the elements in our queue. Okay. And now, if we want to remove the first one, the first element in the queue, this time we have to use another function that is called shift. Okay, so let's have a look. Remove the first element in the queue. So for that, we are going to do queue shift. And what it will do is that it's going to remove that first one. And let's have a look. Console log removing the first element. Let's have a look at the stack. Oh, gee. Oh my God. I hate not having a space after the comma. So sorry about that. Okay, let's run this again. And as you can see now, now we remove the first one, right? If you can see here, we just remove the first one. So this is the implementation of that data structure. This is the way you implement a queue. So remember, for the stacks and the queues, if you're going to, you can create an array and you can use, I'm talking about JavaScript, but Python as well, you can use the push function to start adding elements to your array, to your queue, or to your stack. And then depending if you want to do the last in first out or first in first out, you can use, if it's a stack, last in first out, you can use pop to remove the last element. Or if you're dealing with a queue, which is first in first out, then you have to use shift, which will remove the first one in the queue. All right. Okay, let's continue. Any question about the queues? Oops, and here full screen. There it is. Okay. All right, so now let's have a look at all the info around the queues. So again, the properties, first in, first out. The elements are added at the rear, like at the end of the queue, and removed from the front. And the main operations can be enqueue, which would be using push in JavaScript, and dequeue, which would be shift in JavaScript again, which is removing the element from the front. So what are the advantages? You can process stuff in order, right? So you are ensuring that the tasks or the data are going to be handled in the same order as they arrive. in terms of the complexity, the time complexity, we're gonna be talking about that next week. So I'm gonna skip that one, but I will remind you. We are going to analyze how the time complexity works, and then it's very versatile because we can use this in several different types of applications. Can be if you want to schedule tasks, of course, if you want to process a queue as well, if you want to do buffering of data, and so on. What are the drawbacks? Again, as the same as the stacks, you cannot um, you cannot access any of the elements in the middle. It has to be the front element, always the front element. If we are implementing, another thing is memory. If we have a fixed size for it, if the queue is full, you cannot add more elements until the last one is removed. And we can have errors if we don't catch them and treat them properly. We can have errors trying to remove elements from an empty queue. And then the ideal usage, again, anything that is a queue in any kind of application. The best way to deal with it is this data structure is pretty useful for this. If you want to buffer data, and again, real world scenarios, if you want to use it for like the tickets selling, or sending you want to print a bunch of documents and you send them to the printer. There's going to be like a queue, and there will be processed like in order. And you can also use it for simulations, like it says there. All right. Any questions so far? After this presentation, could we get a valid invite to the GDG Glasgow? We have a Discord in the GDG Glasgow, but we don't really use it as much. I would recommend you to go to the Google Developers Online community in Discord. That's the best way. That's the best way to go. It doesn't work. It does work. Does not work. Okay. Great. Does not work. I don't know if Faye is here. If anyone from Discord, I know that we are streaming that over there. If they can maybe help out with the link. Sorry about that. Invite invalid. I need Faye's help here. Okay, submit, share one there. So if you can go to that one and double check if it works, just let me know on the chat, please. Okay. Yeah, it works. Amazing. Thank you. Okay. You all go over there. I promise you, it's an amazing, amazing place. All right, let's continue. So now let's talk about heaps. This is also really fun. So if I bet that a bunch of you, we all do this kind of stuff. So maybe you have a bunch of ideas and you want to write down everything that you want to do. And maybe you want to write it down in a to-do list, and then you want to write down what you're doing, what is already done. Maybe if you're working, and usually we follow this kind of let's say methodology. doing software engineering, where you have a bunch of tickets to work on, and you have a to-do column doing and done and so on. So if we have to organize and bring some order to these all of these tasks that we are doing, we can use a bunch of tools for doing this. You can use Trello, whatever. So basically all of them, they follow, like, they do the same kind of tasks, which is that we can list everything that we want to work. We can prioritize stuff, like what are the most important things that we want to do, and arrange that. It provides us a way to easily see what are the highest priority items on those lists. And then we can, add and remove items while maintaining that order and that priority that we already defined. So obviously this is always it's a cool project to do, and I will say that it will be really nice if you can do it on your own, like creating maybe your own tool to create your to-do list and stuff, and you can use this kind of data structure that I'm going to explain. It will be like a really nice exercise. But let's talk about just the let's talk about it, because we don't have enough time. And if you get to do something, just show it to me. I would love to see it. Okay, so there is a very very efficient data structure that can help us to deal with these kind of situations, and that is the heap. So let's have a look at how that works. It's pretty fun. So in this case, we have the max heap, and this, what it does is this, we have this tree, okay, where we have a bunch of nodes, and as you can see, the first one, the number is higher than the ones on the bottom, right? Like the children, like the nodes that are right under it, they are smaller in size, and then the ones that are under those are also smaller, and so on. Okay, so the highest priority item, let's say the number 50, is going to be the one with the largest number, and the the largest number is always going to be on the top of that tree. Okay, and yeah, so the rest of the numbers are going to be organized depending on their value. So that's the max heap, is when the node is the first one on top. Then we have another variation of heaps, and this one is called min heap. And as you can see, is the other way around. Like the lower numbers end up having like the highest priority. So as you can see here, the 10 is the lowest number, so it goes up. Okay, but in this case, we're going to be talking about max heap because it's like the most common one. So let's keep, because of time, we're just going to be talking about max heap. Okay, so these kind of structures, they have certain properties. So we can, just by having a look at it, we can see that it's a tree. Okay, it's a binary tree. So that means that each node has at most two elements. Okay, at most two children. So that is why it's a binary tree. Like each node can have tops to children, and then the value of each node, it has to be greater or equal to the values of its children, right? So the children's of a node are always going to be equal or less than the value of the parents. So for example, we have 50 here. we can see this. I think so. Yes. So we can, whoop, all right. We have 50 here, and the children nodes, the values are lower than 50, and so on. Like 14 and 2, they're lower than 15, and so on and so on. Okay, so this is good because this is we can say that this is a order tree. All right, it's a binary tree that follows an order, and what is good with this also that we can have a look at that is we can say that this tree is also complete, and that is because all the rows, like all rows of nodes, are filled from left to right, okay, without any gaps. That means that, for example, we can see here we have left to right, and we don't have any gap in the middle. So if this node were not here but here, then we will have a gap. Okay. So the one of the goals of using this kind of a structure is that we can really quickly, very quickly, remove the highest priority item, and then we can also add um, another element on the top that can be the highest priority then. And then we can do operations to rearrange this tree to follow those conditions that we already talked about, which is like the elements, like the child nodes, the values, they have to be equal or less, and so on. So for that, basically we do two operations. We can insert a node and we can remove the root. Okay, so let's have a quick look at how that will work. All right, so let's see. First, we have this node. All right, we have we're going to start inserting a node, and that's going to be the 13. So that will be what we call the root node, because it's the one that is on the top. So for the all the next subsequent items that we want to add, we need to follow some rules. So first is that we have to add the new node under the first node, right? On the element most at the left. Okay, the element that is most at the left, and we cannot have any gaps. Okay, and that ensures that the tree is complete. So there is a question here. Later, it's asking what is a complete tree again. So in every row, you have like all of the elements. They have to be starting from the left. Okay, so let's go here. So let's go to the last, let's say, row. Okay, we all of the elements, they have to be on the left, and we cannot have any gap within elements. Okay, if we have a gap, then that tree is not complete. Let's keep on having a look at the example, and I think it's going to be more clear. Okay, so that's the condition. First of all, having all the elements to the left, no gaps, so we can have our tree. It can be complete. Then we have to compare that value to the parent, and if that value is higher than the parent, we need to swap those nodes. So in that way, always the highest value is going to be on top. Okay, we're going to go through a whole we're going to go through a whole process of adding nodes, and some of them are going to be higher, and doing the swaps, so you can understand how this works. So we have to like repeat that process. Let's say if we have a tree that has different layers, um, we have to do that process several times until that element goes to the top. Okay. So the thing that we have to have always in mind is that the parent node has to be a higher value or equal to in relation to the key. Okay, so let's say that we want to add a new node. So we are inserting number 10. As you can see, we're adding it to the left. Okay, and because it's less than 13, we can say, okay, we are complying with the conditions for this to be like we're complying with the what is called the heap property. So it's the conditions that we already talked about. So now let's add a number 5, and again, our next available spot is that one. Remember that in this kind of data structure, a node can have at most 2 elements, so that's complete. And we can see that 5 is less than 13, so this is a very beautiful, properly configured tree. So that's fine. Now let's add another one. So because we're adding another one, we have to add it to number, it has to be a child of number 10, right? Because it's the spot most at the left. Okay, so this is 24. So are we complying with the conditions? We're not, right? Because 24 is higher than 10. Okay, so the next step will be to swap it. Okay, so that's what we're going to do. We're going to swap 10 for 24. Okay, and in that way we're complying, but just on that part, because as you can see now 24 is a children of the node 13, and if we check again, 24 is higher than 13, so we have to do another swap. So that's what we're going to do now. So now we do the swap again, and now it works properly because 24 is on the top. The other, like the 2 children, are values that are lesser than 24, and then under 13 we have 10. So that's fine. So we're in a good state again, and there is a name for what we just did, and that is called bubbling up, where if we insert a node at the bottom, we have to keep on checking and swapping if the condition is not met, and we do that all over again until we are super sure that we are complying with the heap property and that everything is well maintained. All right, thank you for the people that is helping out with the questions on the chat. Okay, let's continue. So let's keep on working on this. So we are adding a new node, number 1, and again the most, like the available spot that is at the left, and this is okay. It's valid, so we don't need to do any kind of swapping. Let's add another node, and again the next available spot at the left. So we're adding 15 there, and as you can see, we need to swap, right? Because that 15 is higher than 5, and that's what we're going to do. We're going to swap. So we are swapping, and again 5 now is less than 15, and 15 is less than its parent, which is 24. So we are in a good state again, and we are complying with the heap property. And now let's add a final one, right? Because there's we cannot add more nodes at this level. And we're adding 36, and we're going to start doing that swapping process again. we have to swap 36 with 15, and then we have to swap it with 24 because 24 is less than 36. So as you can see here, there's this cute rabbit jumping, and yeah, we're doing all the swaps. We're doing 2 swaps, and now we're maintaining our property. And as you can see, 13 is less than 36. So everything is working as expected. So good work over there. And if we continue, and if we want to add another node, then we go to the next level because we don't have more space in that level. We go to the next one and we added 3, and number 3 is less than 10, and that's it. We're done and everything is beautiful. Okay, so yeah, this is a very beautiful heap right now. It's in a very good, it's in the very good state. And we did all the bubbling up that we needed in order to organize everything. Okay, so that is how it works when we are inserting a node. So now let's see what is that we have to do if we are removing the top. Okay, so this operation now is removing the root, which is the node at the very top. And as we will see very, very soon, this has some interesting behaviors that are a little bit different than what we just saw when we were adding items. So, okay, let's say that we want to remove the 36. So when we're removing it, we want to ensure that we're still keeping that our property of the heap properties, okay? So these are the steps that we need to follow. So first we remove the root node from the heap, and we are going to replace it with the last element of the tree. So the last element that we have here is number 3. So we're removing this one, and we're going to look for the very, very last one, which is this, and we're going to replace it, okay? And then what we're going to do is that we are going to be organizing all of the elements. So let's see. So on the first step, we're removing 36 and we're moving number 3 to the top. And this is what we are going to have. So obviously, this is not correct because 3 is not higher than 13 and 24. So now we're going to do like the opposite. We're going to do the bubbling this time, like it's not bubbling up, but now it's bubbling down. So we are going to compare that node with its children. And if that node is less than the children, we are going to swap it with the largest child. So in this case, we're going to swap it with 24. All right. So what we do, 3, we compare it with these nodes. And if if it's lower than those nodes, we just have to swap it with the highest one, with the, yeah. Okay, so let's see. We're doing this swap there. And again, as you can see, 3 is still lower than its children. So we're going to be doing the same operation again. So we're going to swap it with the highest number of its children. Okay, so that's what we're doing there. And now that, like, we don't have to do that anymore because 3 doesn't have any more children's. Okay, so it means that now it's in a proper location. And if we have a quick look here, we can see that it's very it's in the right position and it's in the way it's supposed to be. Okay. Now let's think about the implementation. Like we can see this in a graphic way, but what is really the implementation? What is the way that we can implement this as an array? So for this, the best way to do it is using arrays. And let's have a look at how this works. So as you can see here, like this is an array that is ordered, like these are all of the positions of the array. And each array has the element and also like a pointer to its children. So as you can see here, 50 is the parent node, and it has a pointer to 15 and 18, which are the children's. And then if we see 15 is here, and it has a pointer to its children, which are 14 and 2. And you can follow along, like you just have to have a look at all the children's and see if they are related, if they have childs under them. And the way we are organizing the array is in this order, like the first element and then the left, you go to the next level and you start with the left element. So we have 50, then 15 and 18, then we go to 14, 2, 13 and 1, and so on and so on. Okay. So let's have a look. This time we're going to do the implementation with JavaScript because of timing, but I can add it to the slides later. So you can have a look at those. Also with the Python implementation. Okay, then let's have a look at all of the properties, the advantages, the drawbacks, and the ideal usage. So properties, as you saw, is a tree-based structure. You have to satisfy that heap property that we talked about, which is, remember, the parent node has to have a higher value than the child's, and each node can only have a maximum 2 child. And is because of that is visualized as a binary tree. We can use these operations of insertions, insert, delete, and retrieve the top element and the last one, the minimum one, to do the swapping if we are removing the one from the top. And those can be very efficient operations. It's very useful in algorithms like the heap sort. We're going to be talking about that next week. And as you could see, we can have like an order. The elements are ordered, and it provides like an order access to those elements. The drawbacks are that they can be complex to implement from scratch. And the ideal usage, priority queues for these algorithms. And if you want to efficiently find the max element or the minimum one. All right. I can see that you're writing a lot in the chat. I will have a look at this when the session is over, and I can reply to it. All right. But it's interesting to see that you're having those discussions in the chat. Okay, now let's talk about the graphs. And this is very nice. And again, I'm using these examples from kirupa.com, and you can go over there and they have an amazing content. So credits for them, because this example and all the ones that we have been seeing in this session comes from there. All right, so the graphs they are also very cool. They provide a really nice way to organize all the information, and it helps us to understand the relationship between all of these nodes and how they connect to each other, and that connection and the way they interact with each other is actually very important. And yeah, it's all about the relationship between them. So let's start with this example. And I don't know how many young people we have here today, but this is about a comedy like from the US that is called Seinfeld, which is a guy that is a comedian. So we're going to be talking about him and his friends because this TV series was all about that guy and his friends. It was very popular during the 90s, 2000s. I can't believe that was so long ago. But anyways, okay. So we have this guy. He's a comedian. He lives in New York City, and so on. Now he has some friends. Okay, her friend Elaine, Karen. Yeah, I feel old. Yeah, I also feel old. Having to explain this, feel old. Okay, so Jerry has some friends, Elaine, Kramer, and George. Okay, so we can, let's say, represent this friendship relationship with this graph. Okay, we have this guy, and we're going to add all of his friends, and they're going to be connected by the friendship. All right. Uh, then we're drawing, like, and when we're talking about graphs, each of you can see there what are the nodes, and the relation, like that line is called the edges. All right. You can also call the nodes like points or the vertices as well. uh, okay, so if you see a graph and you only see a line like this, it means without any kind of pointer, it means that that is bidirectional. All right. So the relationship that connects those two nodes is mutual. All right. So in this case would be like Jerry considers that Kramer is his friend, and Kramer considers Jerry as his friend. Okay, so this is bidirectional if it doesn't have any kind of pointer. Okay, and when it's like that, it's called an undirected graph. Okay, because all of the edges are bidirectional. All right, they all like yeah, the relationship is the same from one node to the other. Okay, and we can visualize that as this way, like that line. We can also visualize it as a two-way relationship. Okay, so uh, in real life or in applications, that's not always the case, right? So for example, in this case, there was this guy in the series Newman that nobody, like, they didn't like him as much. So for example, Newman would consider that Jerry was his friend, but Jerry would consider that he was not, like, Newman was not his friend. All right, so that is why the relationship just goes one way. Okay, you can say something like, oh, maybe you are in love with a person, but that person doesn't love you back. So that would be like a one way kind of connection relation. All right, so if we have this graph where we can see several types of like directions, not only bi-directional but also like on a one way, that is called a directed graph. Okay, and then let's talk about something interesting also in terms of the graphs, which are the cycles. Okay, so a cycle occurs when we have a path that starts in one of the nodes and goes to another nodes, and then it goes back to it. So for example, uh, we have a bunch of cycles here. For example, we can have one, let's say, that starts with Jerry and then goes to Elaine and then goes to Kramer and then goes back to Jerry. Okay, so that will be a cycle. We can have another one. We can have, I don't know, George, Jerry, Elaine, Kramer, and then George again. That is also a cycle. It's like jumping from one node to another until you start from a node and then you can go back to it. So there's a bunch of cycles there. So it can be Jerry, Kramer, Newman, and Jerry again. Okay. But for example, if we go Newman, Jerry, and we would like George and then Newman, that will not happen because there is no connection between George and Newman, like a direct one. Okay. So we can create a bunch of paths that way. So when we have graphs that have those kind of cycles, that means that are known as cyclic graphs. Okay, so let's see how can we implement this. So let's have a look at this graph. Again, because we're just seeing a line, we can assume that those are bidirectional. Okay, so what are the steps? First, we have to add the nodes. Then we will need to add like the edges between the nodes. And then we have to identify like the neighbors. If the graph is directional, we have to check that we have to respect like how the direction of the edge is done in the graph, and that way we have to follow and represent that in the array. So let's have a look at how could that be represented. Okay, so for example, we have all of our nodes. We can have an array for A, another for B, another for C, another for D, and then we can add like what are the connections between that, like what are the nodes that are connected to A. So that will be B, C, and D, as you can see, B, C, and D. And then for C, it will be only A. For B, it will be only A, and so on. So we can use this kind of a structure to follow, to represent with an array, with arrays, this kind of graphs. Okay, so we can use that. We can use a list, that kind of like as an array. We can use a map. We can use a hash table as well. If we use a map, for example, we can have the key as to be the node, and then the value could be like you know, could be an array with all of the neighboring nodes to that one, and so on. So that's a way that we can implement the graphs, and it can be obviously more complex, but this is the main idea around it, and this is what I want you guys to have in mind. So is there any question about graphs? No, are we good? Okay, so this would be everything in terms of data structures. So now starting next week, the next week, we're going to start and we're going to see everything related to the algorithms. We're going to do an introduction. We're going to talk about time complexity, how to do a bunch of very cool stuff with our algorithms, and so on. So I will share again this URL. If you go to the Google Tech Dev Guide, you will see there a bunch of all of these data structures. There are videos, there are resources over there. If you want to like dig deeper, And yeah, if you have any question, if you want to check anything, you can reach out to me. I can see that uh, yeah, there's a lot going on in the chat. But yeah, I will have a look at this. I will share this video and the slides on the YouTube channel, GDG Glasgow, and I will add some slides with the code in Python as well. Okay. And yeah, that will be all for today. Thank you everyone for coming. Please remember, if you're interested in the web development bootcamp that the amazing Jo Franchetti, she's a DevRel from Spotify, she will be running it for free. It's going to be online around the same, starting like the same time as this one. Go ahead and enroll on the GDG Glasgow website, and we are going to continue delivering a bunch of webinars to support, this series are part of that initiative to support the Code Clan students and also the broader community. Everyone is welcome to join. So keep on having a look, because we're going to continue doing running these webinars. And I hope that you enjoyed this introductory session today, and I hope to see you all next week. And if you have any question, reach out. Just Paul is asking for the link for the web development. So what I'm going to do is that I will share the link for the GDG Glasgow site in the Google Developer Groups communities. I'm going to share it on the chat. And if you go there, you will see a list of all of the upcoming events. And then you can sign up for the third session for this series, and you can sign up for the web development bootcamp that is going to happen. All right. Thank you, everyone, for joining today. And yeah, I hope to see you next week. Bye-bye.